Okay, another important point that if all the peaks and the relevant intensities, the relative corresponding intensities match with the ICDD or JCPDS card, you are comparing it. Well and good, your data is done. But at the same time, you need references to support your data. If reference is not there, then you must recheck again and again, because then you are the first to report that. And the first reporter must be very, very careful. People take years in reporting their data in order to confirm it, right? Confirm it, reconfirm it, and reconfirm it. If these three peaks were matching, but this one was not matching, then and its intensity is 70 or 30 or whatever it is, right? Then this gives you a clue of the second phase inside the material. The peak doesn't come by itself, right? It gives you a clue of, for example, the peaks, if it was a pure phase, then it would look like this. Like this. But if a peak appeared like here, and another peak appeared like here, and other peak was observed here, a little bit shortening appeared here, then all these extra things correspond to the next peak. But the major peak is the one of which you have the 100% intensity. So that one, this is your major peak, major phase. But this peak, this peak, this peak, and a slight shoulder or something like that, they may come from the second phase. Now, the 100 intensity peak of the second phase, if you see that the 50 intensity peak of the second phase is present and the 100 is not present, then again it becomes the story of sheep and camel. If you say the 50 peak is there, then look around, where is the 100? Has it been superimposed by this peak? You have superimposed it here. Where it is? Is it at some angle below your range? Right? If you see the 50 peak, then you must look then for the 100 peak. If there is any higher intensity peak, it should also be there. But remember, interplanar spacing as well as the intensity, both must match the standard data. Now let us move a little bit. Yes, there are two other. When the structures are very, very complicated, then people use, for example, for proteins, for organic materials, people use small angle X-ray scattering, and which is a scattering angle close to zero. When the structures are larger, the dimensions are too large because organic compounds have very long molecules, ligands and different things like complicated structures. But they come toward the smaller angle. Why? Why not larger angle, higher angle? When you go close to the zero, the interplanar spacing increases. When you go away from this zero angle, the interplanar spacing is decreasing. So for large molecules, complex molecules, you go close to the 0. The latest parameter, as I told you, that if this peak is 5.28, it is 4.6. So when you go away from 0, the interplanar spacing decreasing. Our spacings are decreasing, increasing. And these spacings are, when you go away, these spacings are decreasing. These spacings are direct spacings. And reciprocal spacings are decreasing, increasing when you go away from there. Because you are dealing with the reciprocal crystal lattice. And I told you that we reciprocate things where the smaller appear larger. That is the technique. So the D value is the difference between these two peaks. For example, if it was 5.28 and it was 4.6 angstrom, the difference is how much? About about 0.5 angstrom. About 0.5 angstrom. So you can resolve interplanar spacings of that level. If you look into these in the transmission electron microscope, then these are the R spacings. R1, R2, R3, R3, R2, R1 are reciprocal lattice spacing. So when you take the image from the electron microscope, you take the vernier caliper or screw gauge or any micrometer to measure these distances. So what did you do? You reciprocated the angstrom dimension spacings into millimeters and centimeters. So the smaller the difference between two planes within the crystal, the larger will be R, reciprocal lattice spacing. And this, the larger the D spacing, the smaller will be this. So we need to convert smaller into larger, and that is why we are reciprocating things, right? You are modeling basically this room into a small unit cell, but you can't go inside the unit cell, so you expand it and take its reciprocals. So the smaller will become larger and the larger will become smaller. So here you distinguish between spaces, right? So when you go closer to 0 degree, you are increasing the interplanar spacing. And for large crystals, you use small angle X-ray scattering, right? And similarly, they use wide angle scattering, which is at angles close to 90 degree. So obviously, this will deal with smaller crystal dimensions. When you go near to 90, if it is 5.2, 4.6, 3.3, so at 90 it is about 1 angstrom or less than that, right? So when you have small dimensions, then you need wide X-ray angle, wide angle X-ray scattering, and if you have larger crystal, then you have small angle X-ray scattering. And I told you this. Now